got to this stage now with the Automaton head. This is another stage, another level in the moving part. This has got a little servo here, the little blue one, that's going to move the eyes. They don't have much force, they don't take virtually no force at all, but they need quite a large movement of 50 millimeters, hence the fact that this is going to move from there down to the bottom, which is 50 millimeters. This larger servo, much more powerful one, is going to move, raise the whole head, and that's, I think it's 13 millimeters, so much smaller movement but a lot more energy needed. Now I'm starting to think about the mouth, and the mouth I've calculated needs 3 millimeters. I've used these before. These are bellows from cuckoo clocks, and I just wondered whether, by using the little air pump that I've used on other machines as well, I don't think it's going to work, because the air horns that I've used it with, these little pumps, they need very low volume of air but quite high pressure, and I know there's all sorts of things with pressure and flow and everything, but let's try it. Yeah, that's the problem. So it does work, but it's very slow, just because it doesn't pump much of volume of air, and I need the mouth to open and close really quickly. I could use one of these little motors that I use to ring bells and sound cuckoos and things, but I don't think it's going to work, because a movement of 3 millimeters means that if I wrap the chain around a very small spindle, this isn't going to move far enough between the different poles of the motor to be able to achieve anything. It's just not going to do anything if it's not quite in the right place. It needs to have the opportunity to rotate, obviously, because it's a motor. So I don't think that's going to work. Another thing I'm thinking about possibly is an electromagnet. I've got a big one here, and electromagnets are great, or solenoids, whatever you want to call them. I always turn that the wrong way, silly. This has got a big stroke on it, sort of, what, that's 30-40 millimeters, and it draws, I think, about 1/3 of an amp, which is an awful lot of current for something. Don't need that much pulling force. And I started thinking about what else had solenoids, and realised that this is one of the motors out of a normal, very common clock movement. And these have an electromagnet and the armature around it that carries the magnetic force around, and a little gear in the middle with a magnet within it that every time it receives a pulse it turns it once. So clever, simple and efficient. And that's not a bad solenoid. There's a lot of copper on there. It obviously doesn't take that much current, because these things work for, you know, years or more before you have to change the 1.5 volt battery, so it doesn't take much energy at all. So I'm going to have a think about this, and maybe possible to use something like this just to pull the mouth chain enough, the 3 millimeters that's required. I found that if I turn the voltage up to about 12 volts and switch it on, it does have a bit of a pull. I couldn't get any sort of result before that. That's not bad, but I haven't got 11.2 or 12 volts to work with. I want to work with 5 volts, so I assume I need a solenoid with more turns. Looks a little bit strange because I'm lighting it as I want to show you what's going down beneath it, which was disappearing because there wasn't enough light. But lighting from below looks brilliant, and that's what I want to incorporate into the final one, because it just gives it that eerie glow. So we have the head on the top, which can rotate freely, beautifully freely. So on this level we have a very powerful servo motor. Servo motors are used to move things like steering and control surfaces on radio controlled planes and cars and things. So they need to get to a certain position very quickly and very accurately with a lot of power, so they've got a lot of torque on them, and they move fairly fast, and they are controlled by one wire which sends a signal to them from a computer or something, and it tells them very accurate exactly where to move. They usually work through 180 degrees, so this one, which is very powerful, this is connected to the chain that goes to the head, so as this turns it's going to raise and lower the head. And this one is a much smaller servo motor. This is a 9-gram one, which means it's can exert 9 grams at a centimetre or something or other, I can't remember. But it's powerful enough to move the, which one is it? It's the eyes. So this moves the eyes. So I don't want to move it too much because you can damage servo motors, but just see the eyes moving a little bit. I made it a gear so that I can have it turning other bits and pieces of machinery when it's finished to make it look really nice. This is the bare bones basically. This is what's actually required to move the head, and then after I've got this working I'm going to add all sorts of other bits and pieces to make it look really interesting. Moving on down, everything stays together, yep. So this is the next layer down. This works the mouth of all things. The smallest movement, it needed to be about 3 millimeters. So what happens is the chain comes down, we follow it. This is the mouth chain, and it comes down from the head, there's the head, down through a hole, and then through another hole, through this acrylic, round a pulley, and then back up to, if you can see, it goes back up and joins onto the bottom of the head lifting mechanism or servo, because I realised that as the head moves up and down, the mouth, which only needs such a small 3 millimeter movement, also moved up and down. So if you had the mouth closed at the top of the head, by the time the head was leaning down the mouth would be wide open, whereas this compensates for it. And to get the mouth to move, which doesn't sound very difficult, but 3 millimeters, quite quick, rapid movement, actually proved quite complicated. What I ended up doing is to do another one of these fabulous printed pulleys on the 3D printer. This can be moved up and down, oops, like that, with a little motor. Now these are the motors that I've used on lots of machines before. The computer doesn't know where it is, it just sends some electricity to it and it spins. And because this has got quite a small gear on it, a laser cut gear, it doesn't take much to move this rack, and that in turn lifts the pulley, and that in turn opens and closes the mouth. So let's move up to the mouth, which is probably going to out of focus now, but oops, the camera's all moving. So there's the mouth. So as I move this pulley up and down, you can see the mouth moving. A bit of light on it, there you are. So to follow the root of it, we've got the mouth moving, we've got the mouth chain moving there, that's coming down round here, and the motor's moving that. Very simple, isn't it? And we've got a little spring on the back just to give it some resistance to ensure that the mouth always closes, as I didn't want at the resting position when it's switched off for the mouth to be hanging open. So this little spring always pulls that pulley right down, and that in turn always snaps the mouth shut. So that's the stage we're at the moment. So we're using 2 servo motors and a little electric cassette motor, and we need a third servo motor to do this turning, which I thought I had but I didn't, so I've ordered one of those. Now the next thing I'm going to try is to connect these up to an Arduino and the computer and see what actually happens. See if I can control everything. I've wired up all the stepper motors, put longer wires on them so that they can reach to a little breadboard, so I can connect other components to them, and then onwards to the Arduino, which is very exciting because it means I can now think about how to control the head. And the Arduino is plugged into the laptop with a lovely free Arduino development environment installed Fantastic. So now the job is to try and write some software to try and get the motors, the stepper motors that control the head, to work in some sort of ordered fashion to get the head to move. Because servo motors draw quite a lot of current, I'm using my power supply to provide the electricity for the servo motors, and the Arduino is being powered via a USB cable from the laptop, which is fine. So the Arduino is just working on very little current from the laptop and sending signals through to the stepper motors via the breadboard, and the breadboard supplying all the other current electricity that the servo motors need without damaging the Arduino. Because servo motors don't know where they are, or you don't know where they are actually when you first switch them on, I need to tell them somehow where to start off. Because they always work at full speed, this is a little bit tricky because I don't want to damage any of the delicate mechanisms. So I've set them to drop the head down and to move the eyes into roughly the right position. By dropping the head down, it means the servo is just going to be releasing pressure without suddenly jerking it and possibly breaking the chain or anything. So this is what it does so far. I'll switch the power supply on. There we go. Then upload the software so it starts from fresh. And then see what the head does. So that's really good because it's raising the head, it drops it quickly, but then once it knows where it is, e.g. the head's right down, I can slow down the stepper motors so they slowly raise the head and then move the eyes into position. The servo motors are self-contained, they've got all the control circuitry within them, so they just need a wire that goes to the Arduino. Whereas controlling the mouth, which is the next part of it, is slightly different because I'm just switching a motor on and off, so I need to add another component, which is, in this case, a Darlington pair. It looks like a transistor. Basically, it's got two separate components in it that switch large amounts of electricity very easily. So I've connected one end of it, or the base of it in effect, the control, to the Arduino, and then that will allow me to control, switch on and off in effect, this motor that's going to hopefully move the mouth. So I'm going to write a bit of software to see how that works. One of the great things about the Arduino is it has several pins that you can use pulse width modulation on. That means that it will automatically, given a number between 0 and 255, switch the output to that pin on and off very quickly between never being on and being on all the time. That means that I can control how much power this motor gets in effect, or how far it's going to turn. I've set it off to start with, pin 11, 255, so it's going to switch pin 11 full on. Then it's going to wait 2 seconds, because it's in milliseconds. Then it's going to switch pin 11 off, and it's going to wait another second. Then it's going to repeat over and over again. So let's have a look and see what this does. So I think you'll agree that's a little bit extreme. The motor has really got full power, so it's got 5 volts or just under, and it's dropping the mouth right down. If we look at the mechanism, there's the motor, and while it's being given full power, it's turning itself as far as it can. It's lifting this pulley right up, which is opening the jaw fully. So I don't need that much power. I need far less because I don't want the jaw to open that far. So we'll try turning it down a bit and see what happens. I've now set it to 90, so that's under half of the potential power, and it's obviously still moving too far. If you listen carefully, you can hear the windings on the motor buzzing. So I reckon it's going to be so sensitive that I need to put a stop on the motor. It's currently drawing about 20 milliamps, and the great thing about this power supply is that you can see what's going on. So it's 20 milliamps while it's on, and that's okay, that's not too much. It's not going to burn out or anything, leaving a motor on pulling against a dead load, if you like. So I think I'm going to fit some sort of stop so that the mouth can only open so far. Luckily there's a little hole in this part that moves, this lever that moves the mouth. So I've got a little G-clamp that just fits perfectly in it, so I've set it, screwed it up tight so the mouth can only move that far. And with so little current going through the motor, it won't matter, I'm sure, if it stops. If you look at the mouth now, it can only ever go that far, which is fine. I'll try running the software again and see what it does now. Let's have a look. In fact, the motor switch is on and lifts the pulley, that's right, because what's happening now, and that looks much better. So if we look at what the motor's doing, so the motor's switching on, trying to lift the pulley, but can only do it so far. And that equates to a far better movement. The motor will be fine like that, and I'm sure I can speed it up if necessary. Turn that round and let's try speeding it up. But all the wires pulling on everything, so it doesn't really like turning very much. There we are. Let's make it a quarter of a second. So that'll be, well, less than that. Let's do it 200, which is less than a quarter of a second, and see what that does. That's not bad. So we'll change it to a tenth of a second, about 100 milliseconds, and then possibly speed this up more like talking. So if we do that 200 milliseconds, see what that looks like. Be interesting. Yeah, not bad. I reckon that'll be fine. That moves quickly enough, and the noise of, I might have to deaden it with some felt or something to stop it clicking and clackering, but that's not bad at all. It looks a bit more realistic, and the mechanism's coping with it perfectly. If you're still watching, thanks very much for your interest. I also have a YouTube channel where all my videos can be viewed. I'm trying to raise its profile, as YouTube is a better place to store, watch and discuss videos. I would be very grateful if you could visit the channel using the link in the description above and subscribe to it. If I get over 100 subscribers, I can give it a named link which would encourage others to find it. These videos take a long time to make, often longer than the actual inventions, so more subscribers would be a real motivation. Thanks very much for watching.